In this lesson, we are going to learn how to solve radical equations. We are going to work in section 7.4, which is on page 593 in your book. We are going to do problem numbers 1, 2 through 10 even, and then 16 through 34 even. So normally I don't write the directions on the paper and then explain them to you, but in this section it is a little bit important for you to read the instructions. The directions say to solve and check each equation. So each problem that you learn when solving radical equations, that means an equation that has a square root or a cubed root sign in it, you always have to check because they don't always work out. As a little bit of a disclaimer, I am not the check police, as I call it, so I'm not going to look at your work and make sure you checked your answers. However, I will know if you checked your answers based on what answers you put on your answer space. So you're kind of taking a chance if you don't check your answers. The example I use in class is that if you are walking across the street and before you step out into the street, if you don't look both ways, well, one of two things are going to happen. You're either going to end up safe and sound, or you're going to get hit by a car. It's one of the two. So you are taking a chance when you do not check your answers, so I highly recommend doing so. So let's look at problem number 1. We have the square root of x equals 2. So the directions for here, I'm actually going to write out some steps for you. Step 1 is to get the radical by itself. Step 2 is to square both sides. Step 3 is to solve. Step 4 is to check your answers. Okay. So the radical is already by itself on that side of the equal sign, so we're okay right there. But we can go ahead and move on to step 2 and square both sides. Because if you have, let's say, the square root of x and you multiply it by the square root of x, well, you end up with the square root of x squared, which is just x. Okay, that's the whole point of squaring both sides. That way you can get that x by itself to get x equals 4. So to check x equals 4, we take our original equation, which is the square root of x equals 2, and instead of writing that x, we're going to plug in that 4. So the square root of 4 is 2. Now since 2 equals 2, that is a true statement. If you get a true statement, then that means that the answer we originally got works. So that is the answer you put on your answer space, which is x equals 4. Now let's look at problem number 2. We have the square root of x minus 3 equals 0. Well, if you remember the steps I wrote just a minute ago, the first step says to get the radical by itself. So this negative 3 is in the way. So we need to add 3 to both sides to get the square root of x by itself. So now I will square both sides to get x equals 9. So I'm going to check x equals 9. To check it, I take the square root of x minus 3 equals 0. That was the original equation, and I'm going to plug 9 into where my x is. So that's the square root of 9 minus 3 equals 0. Well, the square root of 9 is 3. Bring down your minus 3 and your 0. 3 minus 3 is 0. So now I have 0 equals 0. That is a true statement. So that means that we are okay. The answer of x equals 9 was a good answer. So it checks out, we're good to go. Problem number 4. I've got 3 onto the square root of 2z equals 9. So I need to get that square root by itself. So I need to divide by 3. The reason we are dividing is because whenever you have a 3 right next to a radical, that means multiplication. So the opposite of multiplying would be to divide. That's why we're doing that. So I have the square root of 2z equals 3, because 9 divided by 3 is 3. Square both sides. So when you do that, square root of 2z times the square root of 2z. Well, that gives you the square root of 4z squared, which is just 2z. So that gives us 2z equals 9, because 3 squared is 9. And then you divide both sides by 2 to get z equals 9 halves. You might think, oh, I got a fraction. I don't know how to check it if it's a fraction. It's actually really easy. So we're going to say, all right, we're going to check z equals 9 over 2. Our original problem was 3 onto the square root of 2z equals 9. So I'm going to plug that 9 over 2 in for the z. So that's 3 onto the square root of 2 over 1 times 9 over 2. Since I'm multiplying by a fraction, I went ahead and made that 2 a fraction by putting it over 1 equals 9. So I have 3 onto the square root. 2 times 9 is 18. And then 1 times 2 is 2. And then what's 18 divided by 2? Hopefully you said 9. And now our fractions are gone. That wasn't that bad. If you wanted to do a little bit of a shortcut and say that those 2's canceled and you're just left with 9, you could have done it that way as well. So the square root of 9 is 3. And remember we said when we have a 3 right next to a radical, that means multiplication. So when you pull that square root of 9 out as a 3, it's multiplying by the 3 that was already in front. 3 times 3 is 9. 9 equals 9. That is a true statement, so our answer of 9 over 2 does work. Problem number 6 says that I have the square root of y plus 7 equals 5. So first step is to get the radical by itself. It already is, so we're going to square both sides. So if I were to if I were to multiply the square root of y plus 7 times the square root of y plus 7, well then that would give me the square root of y plus 7 times y plus 7. You can't see a thing we're doing, I'm sorry. So if we're multiplying these two together, which is what it means when we have the square root of y plus 7 squared, I just wrote them both under the same radical. Okay? So when you take the square root of something, you need 2 of something similar, something that's the exact same, in order to pull it out of the radical. Well, I have 2 of the exact same y plus 7s, so they're going to come out as a y plus 7. So that's why it comes out just as a plain y plus 7. And then 5 squared is 25. Subtract 7 from each side to get y equals 18. So we're going to check y equals 18. The original problem was the square root of y plus 7 equals 5. So we're going to plug in 18 for y. 18 plus 7 is 25. And then the square root of 25 is 5. Since that is a true statement, our answer of y equals 18 does work. All right, problem number 8. I have the square root of 3x plus 3 minus 6 equals 0. So I'm going to add 6 to both sides to get the square root of 3x plus 3 equals 6. And then I square both sides. So I get 3x plus 3 equals 36. And the reason the 3x plus 3 comes out of the radical just as so, just look back at the explanation we did for the y plus 7 in the last problem. And then 6 squared is 36. Subtract 3 from both sides to get 3x equals 33. Divide both sides by 3 to get x equals 11. So we're going to check x equals 11. Original problem was the square root of 3x plus 3 minus 6 equals 0. So I'm going to plug in 11 for my x. So I get 3 times 11 is 33. Bring everything else down. So that gives us a 36. Bring down your minus 6. Square root of 36 is 6. Bring everything else down. And then 6 minus 6 is 0. Since 0 does equal 0, then our answer did check out. So 11 is the correct answer. Problem number 10. I have the square root 4x plus 1 plus 3 equals 0. So the first thing I need to do is get that radical by itself. So we subtract 3 from both sides to get the square root of 4x plus 1 equals negative 3. Square both sides to get 4x plus 1 equals 9, because negative 3 squared means negative 3 times negative 3, which is a positive 9. Subtract 1 from each side to get 4x equals 8. Divide by 4 to get x equals 2. So now we've got to check it. So originally we had 4x plus 1 plus 3 equals 0. So I plug in 2 for my x, bring everything else down. 4 times 2 is 8. Bring everything else down. 8 plus 1 is 9. Square root of 9 is 3. And then 3 plus 3 is 6. Notice you did not get the same thing on both sides. That is a false statement. If you get a false statement, then that means that the answer you got does not work. Since the only answer we got was a 2 and it didn't work when we checked it, we will write no solution. But why? Why doesn't it work? At this point right here, we knew that we were going to get a no solution. So we have the square root of 4x plus 1 equals negative 3. You can never have a square root equal to a negative number. You always have to have it equal to a positive. That is why we knew that it would be a no solution at that point on. Okay, we're going to jump to problem number 16 now. For 16, we have the square root of 3x plus 1 minus 2 equals -1. Now, I don't want you to get all excited and think that every time that you have a -1 on one side of the equal sign, that you're going to get a no solution. That's not how it works. What you need to do is get that radical by itself first and then make that determination. Notice how it's now equal to a positive after we got the radical by itself. So square both sides to get 3x plus 1 equals 1. Subtract 1 from each side to get 3x equals 0. Divide by 3 to get x equals 0. Anytime that you have 0 divided by a number, your answer is going to be 0. So now we check it. Originally we had 3x plus 1 under the radical minus 2 equals -1. So now 3 times 0 plus 1 minus 2 equals -1. So I'm going to put in a 0 in for my x and then solve or evaluate. So 3 times 0 is 0. 0 plus 1 is 1. Square root of 1 is 1. And then 1 minus 2 is -1. That checks out, so our answer of 0 was correct. Problem number 18. 3 onto the square root of 4q minus 1 minus 2 equals 7. So we've got to get this by its radical by itself first. Well, if you had 3x minus 2 equals 7, and all I did was replace that radical with an x, what would you do first to get the x by itself? You would add 2 to both sides and then divide by 3. So that's exactly what we're going to do here. So that gives us 3 onto the square root of 4q minus 1 equals 9. And then we divide both sides by 3 to get the square root of 4q minus 1 equals 3. So now we square both sides to get 4q minus 1 equals 9. Add 1 to both sides to get 4q equals 10. Divide both sides by 4 to get q equals 10 over 4 simplifies to be a 5 over 2. Now we check it. Originally we had 3 onto the square root of 4q minus 1 minus 2 equals 7. So we have 4 over 1 times 5 over 2 minus 1 minus 2 equals 7. So 4 times 5 gives us 20. 1 times 2 is 2. Then we have 20 divided by 2 is 10. Fraction's now gone. The scary part is now over. So 10 minus 1 is 9. Square root of 9 is 3. Order of operations, multiply before you subtract. 3 times 3 is 9. 9 minus 2 is 7. So since we got a true statement when we checked it, 5 over 2 is the correct answer. All right, now let's look at problem number 20. All right, this is when the problems start to get a little bit interesting and a little bit long. 20, we have the square root of 48 minus 2y equals y. Well, our radical is by itself, so we're going to go ahead and square both sides to get 48 minus 2y equals y squared. Whenever you have a y squared by itself, or just a y squared in general, you are going to move everything onto the same side as that y squared. It's like it's gravity. It's gravitational force moving everything to that side. So I'm going to add the 2y to both sides to get 48 equals y squared plus 2y. Subtract 48 from both sides to get 0 equals y squared plus 2y minus 48. Now we know how to solve this, hopefully, because we learned that in 8.1. That was when we were solving these quadratic equations. So to solve this, we can factor to be y plus 8 times y minus 6. And then we set both of them equal to 0. Subtract 8 from both sides to get negative 8 equals y. Add 6 to both sides to get 6 equals y. So the bad news is that we have to check both of these answers. So we have to check negative 8 equals y. Originally, we had the square root of 48 minus 2y equals y. So we have the square root of 48 minus 2 times negative 8 equals negative 8. So you might notice that you have a radical by itself equal to a negative number. At this point, we know this can't be a solution, but just in case you didn't notice that, I'm going to go ahead and finish this out. So after you finish working that problem out, notice that 8 equals negative 8. That is a false statement. So that means that negative 8 cannot be a solution. So now let's check y equals 6. Originally we had 48 minus 2y equals y. So I'm just plugging our 6 into both of the y's in there. So 48 minus 12, because negative 2 times 6 is negative 12. Then that gives you the square root of 36 equals 6. 6 equals 6. So the only thing you should write on your answer space is a 6. If you wrote the negative 8 on there, then that would not be correct. If both of them didn't work, you would write no solution. But since one of them did work, you will put 6 on your answer space. Now let's look at problem number 22. On 22, we have the square root of 2x minus 1 equals x minus 8. Well, our radical is by itself, so we can square both sides to get 2x minus 1 equals x minus 8 times x minus 8. So we're going to have to distribute this over here. So that's x squared minus 8x minus 8x plus 64. The way I got that was by multiplying my x times each term in that second set of parentheses, and then my negative 8 times each term in that second set of parentheses. Now I combine my like terms to get x squared minus 16x plus 64. Now we have a squared, and we learned in the last problem that anytime we have a variable squared, you move everything over to that side. So to factor that, we would get x minus 5, x minus 13, and then you would set both of those equal to 0, and then solve. So we got x equals 5 and x equals 13. So let's go ahead and check those. Originally we had the square root of 2x minus 1 equals x minus 8. So we plug in a 5 in for all of our x's. We have the square root of 10 minus 1 equals negative 3. Square root of 9 equals negative 3. The square root of 9 is 3. That is a false statement. 3 does not equal negative 3. So we know our answer of 5 was not correct. So now let's check x equals 13. So we have the square root of 2x minus 1 equals x minus 8, and we're going to plug 13 in for those x's. That gives you the square root of 26 minus 1 equals 5. Square root of 26 minus 1 is 25. Square root of 25 is 5 equals 5. That is a true statement, so the answer of 13 is correct. Number 24, we have the square root of 2x plus 1 plus x equals 7. We're going to subtract x from both sides to get that radical by itself. Alright, so I'm going to read this to you to make sure you can understand it. I messed up a little bit in my problem here. So you should have the square root of 2x plus 1 equals negative x plus 7. Radicals by itself, so we're going to square both sides to get 2x plus 1 equals negative x plus 7 times negative x plus 7. So now I'm going to distribute that negative x times everything in that second set of parentheses, and then the 7 times everything in that second set of parentheses. So I get x squared minus 7x minus 7x plus 49. Combine your like terms to get x squared minus 14x plus 49. Remember, you have an x squared, so you want to move everything over to the same side as that x squared. So we have x minus 4 and x minus 12. So you set them both equal to 0. Add 4 to both sides to get 4 equals x. Add 12 to both sides to get 12 equals x. Okay? So now you have to check them both. So to check x equals 4, you started off with the square root of 2x plus 1 plus x equals 7. So you plug in the 4 to everything that was an x. That gives you 2 times 4 is 8. 8 plus 1 is 9. Square root of 9 is 3. And then 3 plus 4 is 7. That does work, so our answer of 4 is correct. So now let's see if 12 works. You can have it happen to where both work. Or you can have it happen where only one works, or it can be where neither of them works. It really just kind of depends on the luck. So we've got to check x equals 12. So we started off with a 2x plus 1 plus x equals 7. So I'm going to plug in a 12 for all my x's. So 2 times 12 is 24. 24 plus 1 is 25. Square root of 25 is 5. And then 5 plus 12 is 17. That does not work, so that means that 12 is not a solution. So our answer of 4 is the only thing that we write on our answer space. Problem number 26. We have the square root of 2y plus 7 plus 4 equals y. So I subtracted 4 from both sides, that way we could get that radical by itself. So I have the square root of 2y plus 7 equals y minus 4. So now I'm going to square both sides to get 2y plus 7 equals y minus 4 times y minus 4. So 2y plus 7 equals, and we're going to distribute just like we've talked about in the other couple of problems. So that gives us y squared minus 4y minus 4y plus 16. And I'm going to combine my like terms to get 2y plus 7 equals y squared minus 8y plus 16. Now I move everything over to the same side as the y squared. So I have 0 equals y squared minus 10y plus 9. So to factor that, I would get y minus 1, y minus 9, and then set both of those equal to 0. And then solve. So you should get two answers. You should get an answer of 1 and an answer of 9. So let's check those. So we started off with the square root of 2y plus 7 plus 4 equals y. So that's the square root of 2 times 1 plus 7 plus 4 equals 1. So that's the square root of 2 plus 7, square root of 9, 3 plus 4 equals 1, and then 3 plus 4 is 7. So the answer of 1 does not work. So let's try the next one. So to check y equals 9, we originally had 2y plus 7 plus 4 equals y. So I'm going to plug my 9 into all of my y's. So 2 times 9 gives me 18. 18 plus 7 is 25. Square root of 25 is 5. And then 5 plus 4 is 9. Since that does work, our answer of 9 is a solution. So 9 is the only thing that you should write on your answer space. So now we're on problem number 28. So we have the square root of 7x plus 1 minus 1 equals 3x. So you should add 1 to both sides to get the square root of 7x plus 1 equals 3x plus 1. So we're going to square, whoops, sorry about that guys, square both sides to get 7x plus 1 equals 3x plus 1 times 3x plus 1. So we're going to distribute on this side. So that gives us a 9x squared plus 3x plus 3x plus 1. Combine your like terms to get 9x squared plus 6x plus 1. Subtract 7x from both sides to get 1 equals 9x squared minus x plus 1. Subtract 1 from both sides to get 0 equals 9x squared minus x, because 1 minus 1 cancels out to be a 0. So now we factor. This time it's just a greatest common factor we can take out. So you set that x equal to 0 and your 9x minus 1 equal to 0. Just like we did before, it just looks a little bit different. So we have an answer of x equals 0. And an answer of x equals 1 over 9. So now we have to check both of these answers. So to check x equals 0. Originally we had the square root of 7x plus 1 minus 1 equals 3x. So the square root of 7 times 0 plus 1 minus 1 equals 3 times 0. So square root of 0 plus 1. The square root of 1. Square root of 1 is 1 minus 1 equals 0. So that gives us a true statement. So we know that 0 is in fact a solution. So now we have to go through and check 1 over 9. So we started off with the square root of 7x plus 1 minus 1 equals 3x. So to plug in 1 over 9, this one's actually going to be a little nasty to deal with, but we can do it. So we get 7 over 1 times 1 over 9 plus 1 minus 1 equals 3 times 1 over 9. So that gives us 7 times 1 is 7, 1 times 9 is 9, and then 3 times 1 is 3, 1 times 9 is 9. Hopefully you're still with me. So now I'm going to combine 7 over 9 and 1 over 1. We need to get a common denominator, add these. So I'm going to do this up here. Well, in order to add these, they both have to have the same denominator, which in this case would be 9. So that gives us 7 over 9 plus 9 over 9, which is 16 over 9. So now we have the square root of 16 over 9 minus 1 equals 1/3, because 3 over 9 simplifies to be 1 over 3. So the square root of 16 over 9 is 4 over 3. And we have to get a common denominator of 3 in order to combine these or to subtract them. So that's 4 over 3 minus 3 over 3. 4 minus 3 is 1. So we get 1/3 equals 1/3. So in this case, we found that 1 over 9 and 0 are both of our answers. So it's always worth it to check. All right, problem number 30. This one's a little bit of a curveball, but I actually think these are really easy. So on 30, we have the cube root of x plus 6 equals 2. Well, we're used to having this square root where there's an understood 2 right here. But since it's a cubed root, we have to raise it to the third power, which makes those cancel, the radical and the exponents cancel, to give you x plus 6 equals 8, because 2 to the third power means 2 times 2 times 2, which is 8. So subtract 6 from both sides to get x equals 2. Now we're going to check x equals 2. Originally, we had the cubed root of x plus 6 equals 2. So we have the cubed root of 2 plus 6 equals 2. 2 plus 6 is 8, and the cubed root of 8 is 2. Since 2 equals 2, our answer of 2 is correct. Okay, so now we're going to look at problem number 32. So here we have the cubed root of x squared plus 11 equals 3. So we're going to cube both sides. Those cancel, leaving us with x squared plus 11 equals 27, because 3 to the third power is 27. So we can do this one of two ways. We can either subtract 27 from both sides, because I taught you whenever you're left with a squared, move everything to that side to get x squared minus 16 equals 0. Then factor, and then solve. Or what you could have done is, I'm going to take you back to where we had x squared plus 11 equals 27. So I'm taking you back up to this step here. Instead of subtracting 27 from each side, you could have subtracted 11 to get x squared equals 16. And then use the square root method that we learned in section 8.1, which gives us x equals plus or minus 4, which is the same thing we got here. So either method works, it's just kind of whichever one works best for you. So we're going to check x equals 4. So originally we had the cubed root of x squared plus 11 equals 3. So 4 squared plus 11 equals 3. So 16 plus 11, 27. And the cubed root of 27 is 3. So that is a true statement. So 4 is a solution. So now let's check x equals negative 4. So my original problem was the cubed root of x squared plus 11 equals 3. So that's a negative 4 squared plus 11. Negative 4 squared, negative 4 times negative 4 is a positive 16. That's a 27. The cubed root of 27 is 3. So we got 3 equals 3. So both solutions that we found worked. Now moving on to the last problem. We have problem number 34. We wouldn't have done this problem in class. I'm just doing this as kind of a bonus kind of thing. You never know when I might put a problem like this on the test as a bonus. So this is kind of a reward for being able to have time to watch these videos. So we actually have a radical on both sides of this equation. So general rule, get at least one of them by itself. Well, the 3x and the 5x minus 1, both radicals ended up being the only thing on each side. So we can go ahead and just square both sides. So that leaves us with 3x equals 5x minus 1. And then this one's actually really easy. Just solve for x. So far I subtracted 3x from both sides. So you want to get all of our x's on one side, and you always move the smaller one. Then you add 1 to both sides to get 1 equals 2x. Divide by 2 to get x equals 1/2. So now we're going to check it. Originally we had the square root of 3x equals the square root of 5x minus 1. So if we had 1/2, that gives us 3 over 1 times 1 over 2. 5 over 1 times 1 over 2 minus 1. So that has 3 times 1 is 3, 1 times 2 is 2, 5 times 1 is 5, 1 times 2 is 2. So we don't know what the square root of 3 over 2 is, but we can keep simplifying this side. So that's 1 over 1. So I'm going to do this up here. 5 over 2 minus 1 over 1. Have to have a common denominator. So that's 5 over 2 minus 2 over 2, which is 3 over 2. So even though we don't know what the square root of 3 over 2 is, we have the same thing on each side of the radical, which means, or each side of the equal sign, which means that is a true statement. So our answer of 1/2 was correct. I hope this lesson has helped you, and I wish you the best of luck.